CER, and today I'm going to talk about my action research using claim evidence and reasoning in the classroom. The purpose of my action research is to enhance the student understanding of how to accurately make a claim, provide accurate evidence, and explain how and why the information is relevant. The strategy will help students extend their knowledge to answer questions and solve problems in science. It will also help students to enhance their argumentative writing, their analytical thinking, and higher order thinking skills. My problem statement is that it became very apparent that my 8th grade classes, when they were given a lab or text, the students had a very hard time developing a claim, presenting accurate evidence, and providing a proper rationale for why that evidence they provided is significant to the claim. The problem that I will address is the lack of understanding in developing a claim, finding the proper evidence to support the claim, and connecting information to scientific principles. My action research questions are: how will the use of the graphic organizer affect a student's ability to make a claim, provide evidence and reasoning? How can modeling of the claim, evidence, and reasoning framework help students to develop an understanding of the strategy? And how many students will increase their knowledge of the claim, evidence, and reasoning framework? My literature review, source number 1, was a study that looked in depth at the claim, evidence, and reasoning strategy over a year period with a 5th grade classroom that analyzed student work to determine student strengths and weaknesses to determine how to properly implement the framework to meet all students' needs. National science education standards and reform documents include a focus on having students use evidence, construct explanations, and engage in argumentation, which is exactly what we want our students to do using the claim, evidence, and reasoning framework. Literature review source number 2 was based on research from Kennedy and Folks that found that writers were reluctant to use the claim, evidence, and reasoning framework, and those students were particularly the English language learners. Those students had a hard time making a claim and making a connection to scientific principles. It was then determined that many students understood the vocabulary, yet they struggled with using the right words to explain those scientific principles. And for my last piece of literature review, I looked at a study which looked at how the Common Core standards state that students should be able to write arguments to support claims in an analysis of topics or text using valid reasoning and relevant and sufficient evidence. Again, these standards are key to literacy proficiency across all subject areas. The use of the claim, evidence, reasoning in a science classroom can provide students with a deeper understanding of big ideas and create a positive experience for students when writing analytically, and that framework, again, it should be used across all subject areas. My research design and methodology, the data that I collected was from both qualitative and quantitative data. I collected the data through a pre-test using claim, evidence, and reasoning, modeling and observations, and the use of formative data in the form of a graphic organizer, and a post-test. These methods, again, will help me achieve the answers to my research questions and attain conclusions to my problem statement. My data collection source number 1. I collected quantitative data from a group of 8th grade students that totaled 60 students that used the claim, evidence, and reasoning framework through a pre-test. The pre-test consisted of a scientific article that was given, along with a graphic organizer that consisted of 3 questions. And those 3 questions were: what do I know? How do I know it? And how does my evidence support my claim? The pre-test was graded on a rubric. From the pretest, I found that 14 students had a good understanding of the framework and could complete the graphic organizer with an accuracy of 80% or above. 20 students were somewhat able to complete the framework, being able to complete at least one section accurately with an 80% accuracy. And then 26 students did not understand about how to go about completing the claim evidence reasoning framework at all. The purpose of the data analysis is to improve instructional practice, influence a positive change in the classroom, and improve student outcomes by making informed decisions that are based on data. So based on my quantitative data from the pretest, 76% of students scored the lowest on connecting their reasoning to their claims using scientific principles, as well as scoring low on being able to provide accurate evidence using numbers, while only 24% of students could thoroughly use the framework. Here is a graph of my findings from the pretest. 26 students did not have a good understanding of the framework. 20 students could complete at least one section of the framework, and then it shows that the 14 students thoroughly understood the framework. Data collection for my source number 2. I collected qualitative data by reviewing trends within the students' work over a period of time by analyzing each section of the claim, evidence, and reasoning using questions on a graphic organizer. And those included the claim, which was a one-sentence answer to the post question that should describe the relationships between the independent and dependent variables. Evidence. The evidence should accurately provide certain evidence and data from labs, texts, and articles using numbers. The reasoning provides an explanation of how and why that data you provided supports your claim, and it should provide an in-depth justification as to why this evidence is important. Again, using those scientific principles such as laws, definitions, and theories that connect the claim to the evidence. It was evident that many students were struggling with providing accurate evidence and making a connection between their reasoning to their claim using scientific principles. Based on that trend, I modeled what data is and where accurate data is found. The modeling I did when students were conducting labs and when students were asked to support their claim using evidence from scientific principles. To help students with this section of the framework, I differentiated sentences for each student. Based on students' work on the graphic organizers, over the course of the few weeks, 70% of the students had an increased their understanding of completing the claim, evidence, and reasoning with at least 80% accuracy, while 30% of students could now thoroughly complete each section of the framework. Here on this chart, it shows that 33% could thoroughly understand the framework, while 30% could now complete at least one section of the framework, and 37% did not have a good understanding of the framework still. For my data collection number 3, I collected quantitative data from students' scores on the claim, evidence, and reasoning post-test. It was graded on the same rubric as the pre-test, and the post-test consisted of the same scientific article with the graphic organizer that consisted of the same 3 questions as the pre-test, and it was given to the same 60 students. Students who understood the claim, evidence, and reasoning framework and could now complete the graphic organizer with an accuracy of 80% or higher increased from 14 students to 25 students. The students who were able to complete at least one section of the claim, evidence, and reasoning framework accurately with an 80% accuracy rate decreased from 20 students to 15 students. And the students who did not understand the parts of the claim, evidence, and reasoning framework went from 26 students who could not complete any of the sections to 20. Overall, on the post-test, 41% of the students could now thoroughly complete each section of the framework, which is a 17% increase from the pre-test score. And now 58% of the students who were still learning how to properly connect their reasoning to their claim using scientific principles and accurately citing data. That actually decreased by 18%. Here is another graph that shows now 20 students did not have a good understanding of the framework. 15 students could complete at least one section of the framework, and now 25 students thoroughly understood the claim evidence reasoning, which was a substantial increase from the pretest. My future action plan. I intend to continue to increase student understanding of the claim evidence and reasoning framework by differentiating graphic organizers, which will depend on the student's understanding of the framework. I will provide students with more small group teaching while grouping students based on parts of the framework where students are not understanding while using modeling. I will implement this in 2 of my science classes to prove that the more graphic organizers are used throughout the framework, the more students' understanding will increase. Conclusion. It is apparent that the claim evidence and reasoning framework should be utilized in order to increase students' argumentative writing, which will help them be successful in writing across all subject areas. The overall goal of my action research is to develop a plan of action to change the way my PLC uses the claim evidence and reasoning framework in the classroom by using various strategies. Based on both methods of data, it was apparent that modeling and the use of graphic organizers did ultimately increase students' understanding of the claim evidence and reasoning framework. My reflection. After this course, I have come to the realization of how important action research is to guiding and reflecting on teaching practices. I recognize how essential data collection is to determine student understanding in the classroom. It is important to analyze data trends, which will allow me to understand all my students' needs and how they learn, which will help me determine which instructional strategies to use to accommodate each student. When conducting action research, there needs to be a purpose in mind. I have gained an understanding on the importance of the scientific-based research to determine the validity of given information. Thank you so much for listening to my action research on using claim evidence and reasoning in the classroom.